4 power SoC trends. Again, just to familiarize you, same block diagram we talked about earlier, and this is the power SoC. Interfaces with the battery, provides all the power to the subsystem, and also provides fuel gauging. So before I get into it, I think an important thing to understand is the operating profile of a wearable device and how it differs from a smartphone. A wearable device spends a lot of its time in standby mode and occasionally wakes up to do sensing and then communicate with the edge. Basically what this means is, in terms of battery consumption, standby mode consumes about 25% of the battery power. The other 50% is sensing and 25% communications. So I'll explain why that's important in the next few slides. I'll just go over the power trends. As I mentioned, ultra-low standby current will be important because 25% of the battery consumption is in standby mode. That means the microcontroller, the power SoC, all need to have very low quiescent current or very low static current. The second trend is load-optimized DC power regulators. As I mentioned, 75% of the battery consumption is when the wearable device is either sensing the surroundings or communicating with the network. And the third trend is smart battery management. A power SoC will need to embed a very high accuracy fuel gauge algorithm to optimize the battery operating time, and also a smart charger that can manage the power source for fast charging. And I guess to summarize, the reason these trends are important is because users want their wearable device to operate for the longest amount of time without having to recharge it. And when they do have to recharge it, they want to be able to charge it fast. So now we'll show how Maxims is addressing those three trends. This is the Max 14676, our Pmic for wearables. We have an embedded fuel gauge, which uses Maxims' proprietary model gauge algorithm. We have a smart battery charger, so that the device could charge from a USB port or another higher voltage power source up to 28 volts. And we integrate multiple very efficient, low quiescent current power regulators so that maximum efficiency in DC to DC conversion is achieved.